All right, welcome back. Let's solve this problem together about the certain inequality, and then we're going to graph that solution on this number line. Okay, so the letter variable in this case is p, so we're going to isolate it in this case by subtracting 4 on both sides. 4 minus 4, down we get 3p, put it over here, is greater than 1 minus 4 is negative 3. Gotcha. And then what do we do to both sides? We can divide both sides by 3. 3 divided by itself is 1. Gownage. Negative 3 divided by 3 is negative 1. Okay, p is greater than negative 1. Let's proceed to negative 1. Open circle or closed on negative 1. Can negative 1 be included as a solution? Is p allowed to be negative 1? No, it's not or equal to. It's just more than. So I'm going to negative 1. I'm putting an open circle to imply that p can't be that number. But it could be more than it. So more than means to the right. Right? P is getting bigger and bigger and bigger. Okay, there it is. Let's do the next problem together. Here we go. You are a scientist, and you're collecting soil samples for an experiment. You're currently on a hill at an elevation of 200 feet. Okay, so we're way up here, and we've collected 5 samples. Okay, envisioning that, 200 feet up, we've collected 5 samples. You're digging straight down, right, onto this hill, digging straight down, and to maintain consistency in your samples, and can take only 1 sample every 10 feet down. Oh, that's interesting. All right, so 10 feet is a sample, 10 feet is a sample, 10 feet is a sample. All right. In order for your results to be conclusive, you must collect at least 12 samples. Okay, this problem is a meal. Which inequality represents the remaining number of feet you need to dig to collect enough samples? All right, scientists, get your geology hat on. Here we go. Well, let's do what we've talked about earlier today. Let's construct this problem piece by piece. Let's gravitate over here to this concept of at least 12 samples. If we need to collect at least 12 samples, let's say that we're doing greater than or equal to 12. All right? Hopefully that makes sense because we need our samples to be 12 or more. Okay? 13 samples or 14. So it'd be cool if 13 was here or 14 was here. All right. I also remembered that we've already collected 5 samples. Oh, so that's cool. All right. So we have 5 samples already. And we need to collect more samples. So now that we have this setup of 5 samples already collected, and we need to have at least 12 samples total, we could even start to feel how many samples we need to collect, right? 5 plus what is 12 or more? I'm already getting that number. Are you getting that number, right? We can think about that, put that in the back of our mind. Let's read the question, though. What inequality represents the remaining number of feet? The number of feet you need to dig to collect enough samples. So the unknown or the variable is the number of feet, whereas this setup, this entire thing, was about samples, at least 12 samples, collected 5 samples. All right, so the challenge of this problem will be for us to leap from the samples and express it in feet, or the other way around even, to find the link between the two. Here's what we mean. Let's relate the feet down, right? We're digging down, right? You're digging straight down to the number of samples. Embedded in the problem is that it says, where'd it go? We take 1 sample every 10 feet down. Okay, so let's say this is 10 feet down. That would be how many samples, right? 10 feet is 1 sample. That's cool. So what I like to do is create a bit of a pattern. So 20 feet down would be 2 samples. All right, I'm comfortable with this so far. And so the inequality wants the number of feet that we need, how many feet down we need to go. So that's the thing we don't know. All right, that's kind of cool, right? So we're graduating from numbers to variables. And so if we want to bring samples here, what would this be right here? What would be the related samples to F feet down? It's crazy. Well, let's think about it. How do we go from feet to samples? What happens to 10 so that it becomes 1? What do we do to 10? If it's a constant rate, right, you could think of it as divide by 10. Isn't that cool? Right? Divided by 10, it becomes 1. Is it the same for the 20? Divide by 10, becomes 2. Rock and roll, we found our pattern. So in order to go from the feet down to the samples, we have to divide whatever the feet is by 10. And that will be the number of samples. That's challenging, telling you. Let's go red here. Yeah, maybe after the fact it helps. 10 to go to 1, divide by 10. 20 to go to 2, divide by 10. F to go to F divided by 10, divided by 10. This is the number of samples based on feet. Wow. Fancy. Okay. So the number of feet divided by 10 is the number of samples. Okay. It's starting to make more sense to me. Let's divide, let's subtract 5. Subtract 5 on both sides to isolate F. This is gone. We'll get F divided by 10 is greater than or equal to 7. And then to isolate F, we're going to multiply both sides by 10. It's the inverse operation of divide 10. All right, and we'll get feet is greater than or equal to 70. All right, so the number of feet that we need to dig is 70 or more. Nice work. Okay, here's something cool for you fellow scientists out there, if I can call myself a scientist, I don't know. If you're thinking scientifically, if you're thinking geologically, feet down, if you're digging down, that actually implies a negative direction. Right? Maybe you've heard of below sea level. You could actually be negative 10 feet would be 10 feet below sea level. In fact, here's what we mean. You could have feet down technically mean negative 10 feet down, 20 feet down, all right? As such, the feet down, if you're going to be technical about it scientifically, can be a negative number, all right? So that you can actually go down by a certain amount, so that would be a negative number of feet. Now, friends, if we're going to be technical scientists, geologists, I can pull that one off, how do we go from the feet down to samples? Because we know that samples can't be negative. How do we go from negative 10 to 1? How do we go from negative 20 to 2? It does have a division, and now if you look closely, it's divide by negative 10. See that? Isn't negative 10 divided by negative 10 1? Yes. Isn't negative 20 divided by negative 10 2? Yes. So if feet can be negative, we have to divide this, whatever this number is, by negative 10. That's what we did each time. Divide by negative 10 to get here, divide by negative 10 to get here, divide by negative 10 to get here. And the reason we're doing this is actually really fascinating on a scientific level. So fascinating, in fact, that we're going to create more geological space for the problem. All right, yeah, I'm going to put you over here. And now let's set up the problem in the same way. Boom. All right, let's go black. So we have the number of samples, 5, plus, right, just mirroring this, F over negative 10 is greater than or equal to 12 samples. Now, let's solve a different way. Let's solve a different way. You notice the setups were similar, right? Just now we're talking about that you can go down 10 feet, and so down implies negative 10 each time. I could multiply both sides by this denominator of negative 10 in order to simplify the problem and to create some interesting observations, and times negative 10. Using the distributive property, negative 10 times 5 is negative 50, all right? Negative 10, right, multiplied by this denominator here, right? Negative 10 in the numerator divides negative 10, that becomes 1, and that leaves just F. And then 12 times negative 10 is negative 120. And you may recall, whenever multiplying or dividing both sides of an inequality by a negative number, the inequality switches direction. So you'll notice greater than or equal to now becomes less than or equal to. Worth saying again, multiply or divide both sides by a negative, the inequality changes direction. Now here's the payoff, why we spent this time talking about geology. We have now been able to transform a problem about samples to feet. And this was the goal. We've gone 50 feet down already. Isn't that true? For 5 samples, 10 feet each time. And we need to go below negative 120 feet down. We need to go below this amount to get the number of samples for our experiment. Let's go ahead now. If we add 50 to both sides to isolate f, this is gone. And we'll get the number of feet has to be less than or equal to negative 120 plus 50 is negative 70. So, right, potato, potato. But this one, scientifically speaking, is that you need to dig below 70 feet already negative. 70 feet below the ground is negative 70, and you need to go below that, right? This is more conversational. This one over here on the right. The feet has to be 70 feet or more of digging, right? You think if that's, I need to dig 70 feet or more. But geologically speaking, this could imply 70 feet above because it's positive 70. This is more scientifically true, okay? But really, it's all how you say it. There's merit to both of these. All right, shovels away. Good work. Here's a problem about a humidifier, all right? Read that and then see if you can answer the problem along with this number line challenge. Give that a try.